Okay, welcome back. So we're finally here. This is a bit of a turning point in the course. Really important section, not to scare you too much, but really fundamental to how SQL and MySQL are used in the real world. So this is a section all about relationships and also something called joins, which we'll get to in the second part of this section. So let's focus on the relationships part first. So far in this course, we've been working with very simple data. Things like books or users, where we only have a couple of columns per table. And that's been by design. We need that simplicity in order to focus on what's important, to isolate the different features that we're talking about, whether it's functions or logical operators. It's much easier to teach those when we don't have 20 different tables to worry about, and we can just basically drill down into one table and focus on that. But that's typically not how the real world works, where, we might have a users table, but there's no site that really can just get by on having users unless it's featureless. There's plenty of other things that need to go along with users, whether it's comments or likes or tweets or posts or photos or any sort of, order, transaction. There are all these different things that we could have alongside users. So we've been working with simple data.
But that's about to change.
Real-world data, unlike what we've been working with, is really messy typically and interrelated. There's a lot of connections between data. So some of those things I talked about with, let's say, users, if we're working with just a simple blog site, so nothing like a Facebook or a complex social network, just a simple blog, we still need to have user data. We need to have information about posts, blog posts. We also need to somehow keep track of comments and then tags. And that can get pretty complicated already, not to mention things like advertising and tracking not only ads on their own, but how ads are related to users and what users are clicking on and not clicking on. There's so much data that just from a simple blog site, something that may not seem that complex, there's so much stuff that we could store. So we're going to focus on how we work with interconnected data in the next couple of sections. So we're no longer focusing on one table. We're going to see how do we work with two tables or three or four that are related. So not just tables that exist independently, but tables that reference one another and are interconnected. So let's get going. And the first thing that I want to do is go back to our books data. So remember our books table. Don't worry, we're done with it. We're not going to be typing any books code. But on its own, it was really simple. We had a books table with author first name and last name, a book title, released year, a page count, in a stock inventory, I believe, a stock quantity. And I think that was it. So again, on its own, that just represents a single book. But you can't really do much with that. But if we were running a sort of book site where we sold books, at a minimum, we would need to keep track of things like versions. So we didn't even talk about this, but there's often multiple versions of a single book. If you go on Amazon and you look at a book, let's say Harry Potter, the second book, Chamber of Secrets, well, there's going to be the initial British release, the UK version as a hardcover, and then there's a paperback, and then there's the American version, and then there's a paperback. There is a full color illustrated version that came out relatively recently. It looks pretty cool, that has these giant illustrations. It's the same title. How do you keep track of that? Is that a different table? Or do you just make a separate book for every one of those? But if you do that, then how do you make sure that they're connected? Because when I go on Amazon and I look at the hardcover, it also will show me below, some people also buy paperback version, or it's also available in, 25, 40 different languages. So there's all sorts of things to worry about just with versions. But then we have authors. Well, that might seem straightforward. We have an author, first name and last name, 2 columns on our books table, but that's not sufficient when we have multiple authors. So some books, a lot of books have multiple authors. What about if it's a research paper that we're selling or a journal that has dozens of authors potentially? So there's a lot of things to keep track of there that we can't really do right now. We only have room for one author in our columns. Then a whole big thing is customers. If we're doing a bookshop online, books on their own is great, but we also need ways to keep track of users, or customers is what I'm calling them in this case. So customers on their own also can't do that much, but we might keep track of their email, login information, Of course, we wouldn't just store their password directly, but for simplicity's sake, let's say we're keeping track of password and email so that they can log in. And then there's a whole bunch of other things. Orders. So if customers want to order books, how do we store that? We need to create a new order, and it needs to be associated with a customer who created it. It needs to have address information maybe. It needs to have the contents of the order. Are there books? One book? How do we support that? How do we handle that? What about if we're working with dates and times and we need to keep track of when a return period expires? So we need to have an order date and then keep track of 30 days or 60 days after that or whatever it is. Then we also need to store or somehow keep track of the transaction information. Addresses for billing address, not only shipping address, the type of shipping, the billing information. There's so much to store. And then a whole other thing is reviews. So if we go on Amazon or pretty much any book site, any book that you look at will have dozens or hundreds, sometimes thousands of reviews. So we've got reviews there, ratings, the number of stars, but then also a title for the review, and then a caption, and then the actual content of the review, which may be 10 characters, I hate this book, however many characters that is, or it could be a giant paragraph, someone's love letter that they're writing to a book. So how do we account for all of that? And then the last thing that we'll talk about are genres. So you may think that we could just get away with storing this in a book, which we absolutely could. We could just have one genre, but many books don't cleanly fit into one genre. We might have a vampire novel that's also historical fiction because it's set in Victorian period England. Or we might have, a sci-fi book that has elements of fantasy, or who knows, you can have all sorts of, cross-pollinated genres. So only assigning one genre might not be that useful. We may want to have a bunch more. And in fact, on Amazon, you can see there are books that will have 2 or 3 different genres or different tags associated with them. So what I'm trying to show you here is that we were working with books on their own, but in a typical app or a typical website that has to do with books, and a bookstore in our case, there's a lot more that goes along with books to make anything functional, to store any important information. And this is, maybe half of the tables that you would need to get away with, kind of the MVP or the bare minimum. There's still many other things. Something like orders, for instance, might actually need to be split into a couple of tables. We might need to have an address section or an address table. We might need to then have a separate billing table. We might need to have shipping. There could be all different tables that we could split it up into. So this isn't to say this is the end all be all. This is just that there's a couple of other tables that we need to consider at the bare minimum. Okay, so we'll stop here. In the next video, we're going to identify some of the different types of relationships between data. At a high level, what are the different types of associations? And I'm back. I totally forgot to show you this. Even though I wrote a note to myself, I totally skipped this. So I'm back after recording this, adding this to the end. I want to show the schema diagram that I really think highlights how messy data can be. So I think I showed this early on in the course. This is just a potential schema for Facebook, and it's definitely incomplete. It's maybe a tenth of the number of tables that Facebook has. But you can see, just to store basic things like events and users, we have Facebook event, we have event membership, which is related to RSVP states, which is also related to venues, which is also related to groups and to workplaces and to Facebook profiles, and it just goes on and on and on. So what I'm trying to show you is that data can get messy. And in fact, here's another super intimidating schema. This one is a little bit crazy because it has to do with storing a protein database. I saw some article on IBM and I believe MIT. Unfortunately, it's a very low quality image, so you can't actually see the tables. But each one of these little rectangles is a separate table, and every line is a connection between the tables. Now, this is the worst I've ever seen, the craziest, and I think that was the point, is that they're trying to just show you, they're never going to actually look at this to try and understand anything, but they're trying to show you how complex protein information is when you have all these different combinations and permutations for a given protein. Without going into too much detail here, this isn't a bio course, but the way that a protein is folded, the same structure, basically the same amino acids, depending on how it's folded, can drastically change the features, if you will, basically what the protein does, how it behaves. And so this is a way of documenting, using SQL in some way, the structure of a protein using a database. Okay, so not to scare you there, I just think it's kind of a powerful image. Although grainy, it is powerful to see basically some really messy, ugly, gross data that can be supported using tables. It just doesn't look pretty. But that's the important part, and kind of the point of this video is I wanted to get you prepared mentally for working with some more complex data, although nothing that looks like this.